the thing with PhonePe is whatever we do, right, it gets used every day, all the time by a lot of people, correct? So when we have to use a new technology, we try to take it a little slow, understand how to build, and how to roll it out at scale to a lot of people. You have what 500 million plus customers, right? So yeah, so we based on that we sort of went about building some stuff. We are not there yet. I would say we have just kind of started on our journey, and we decided to take inside-out approach towards AI, where basically we start building some stuff which can help the company internally, and then keep building till the point of time we can make people's lives easier at scale, right? So I would say we are about 30% of the way to being out to consumers at a very large scale. So I'll just quickly go over some of the stuff which we have found useful, which we've built and we've kind of found useful. We tend to work in a federated model in the company where we encourage people to build out stuff that they like, empower them, and if it works out well, we grow them into platforms which are widely rolled out across the company, right? So yeah, so I am going to mostly talk about three of the projects that we have found useful. So first is the AI/ML platform that we have. The other is the Agent Hub, and the third is the Sentinel AI Agent Framework. So as you can understand, we invested early in ML because we are in the financial domain. And a small anecdote, our fraud detection system, there were like 5 people in the company writing code, I think at that point of time. I was running transactions, another guy was writing the fraud detection platform, okay? So both of those kind of went live together. So, and so we kind of invested in ML a little bit early. It is not our whole fraud detection system, but it plays a significant part. So we sort of augmented that platform to also handle ML models and vision models across the company, right? So yeah, so in the AI/ML platform, we have the core platform. We had the core platform already, and on top of that, we started building two stuff which would be the bread and butter for most of the applications we foresaw would be coming up at least towards the short to medium term, right? One was basically interacting with models. The other was looking up information, right? So what we built, so Godric is the layer which we yeah, this is the layer which we had actually built for all the application layers sitting on top. And so what are applications? Let's say, for example, simple tools. Like we have a tool where all RCAs are shared, right? And some of these RCAs we also have to send to external agencies. So we want to create a summary of all the RCA, the timeline, the business impact, and so on and so forth. So this is an application which should talk to a model, maybe, right? And so we are mostly a Java shop, right? I would say 99% of our code, backend code is Java. And so we have a agent framework. We'll get to that later. And we have Python agents, which are written. We primarily use LangGraph and Pydantic AI, right? And we have some open source agents, which we also deploy internally and use. Plus, we have some vendor software, the usual stuff like SonarQube and all that. So everything is routed through Godric, right? On the infrastructure side, we again started investing in getting GPUs and access to models from at various layers. So we use models which are provided by the OpenAI platform on Azure, right? We have GPU servers on Azure, which we basically use to run open source models. I'm not sure how many people know, but PhonePe mostly runs all of its services on our own data centers, right? So we have GPU servers there where we also host models. But you understand, right? Running larger models needs some re-architecture in your data center cooling and networks and so on and so forth. So the build out will take what time it takes. So we did not want to stop the progress there. So we are also heavily utilizing Azure and other vendors to fill in the gap in the meantime. So what does Godric do? It basically provides, so one thing I'd like to say is like payments is a scale business. You know what I mean, right? You don't make a lot of money on a single transaction. You end up making some money from a lot of transactions, you know. So it kind of makes sense to be really efficient about everything. And we are a little bit, how should I say, obsessive about this efficiency side of things, right? So yeah, so basically running some models on GPUs kind of gives us better performance. And one of the things that would bring us efficiency is to be able, you know, we operate mostly in India, right? So the traffic goes like this. So towards the morning, there would be some peaks with a lot of people doing transactions. And again, towards the evening, there would be something. And towards the night, it would be much lesser traffic than most of the day, right? So what happens to all the GPUs that you have basically deployed or, you know, hired or whatever, right? So you kind of, that's the time you basically use to run your batch jobs, you know, like attribute extraction from whatever, product images and storefront images and so on and so forth. So those can be run on batch, right? So the Godric basically provides number one, it's OpenAI compliant. So we had to do that so that anyone trying to use any tools, libraries, software, they would be instantly able to use Godric without having to, you know, make a lot of changes in the software, right? Then it does a few very critical things. So PhonePe is heavily regulated by multiple agencies. Mostly whatever agencies you know the name of, they come and run one audit in PhonePe. Okay, I think we run more than 50, 60 audits every year from different agencies, internal and external, right? So for us, and we are a little bit of nut about users' data and privacy and so on and so forth. So there are authorized, so it does, Godric has an authorization model where we can strictly control where if any customer's data needs to be sent, it needs to be localized in India, or maybe needs to be run on our own GPUs and so on. So all this authorization model is managed in Godric. Then we have Quota. Obviously, it's a common platform which abstracts out a lot of models. You don't want some rogue app basically taking up everything. Then you have safeguards where we use models again to kind of do prompt detection and profanity detection and stuff like that. And we have a routing experimentation layer. Audit obviously is basically what people are querying and what they're sending. Again, this is part of the compliance process. And yeah, so experimentation and routing basically lets us take different use cases, run it on two types of models for different cohorts and figure out what is giving us better results at the end and so on and so forth, right? So all this is completely controllable using configurations and consoles, and the front end remains very simple. Front end is whatever you want it to be. Basically anything that works with OpenAI will work with Godric, right? So yeah, so this basically brought us a lot of value. You know, it kind of unlocked. We could let people work with some data and information, and still ensure that nobody's data is going out of country, out of bound. Like whatever compliance controls are necessary for the domain are all applied, yet people have the flexibility to do some experimentation on their side. And for all these systems, we basically have internal platforms like audits and authorization, authentication, quota management, and routing experimentation. So we just leveraged all of the platforms we had built and abstracted out in Godric. So once this was solved, the other stuff, okay. So what we needed to figure out was how to deploy models and get whatever we wanted, like the open source models, right? And get it integrated into our ecosystem. So we have our own container orchestrator, right? It is open source, but yeah. So our GPU servers are basically managed by the orchestrator itself, right? And there is an internal version which basically supports GPU slicing, etc. And we can run all these models as containers. So we have our own object store. And the base weights, like whatever models we get from Hugging Face, and they go there. All the adapter layers are also deployed from there, and the whole models are actually deployed as a fully formed Docker container. Okay, with the GPUs mounted directly into the containers. Now, depending on the model, we'd be using VLLM and or SGLang. Some models give better support on SGLang. Some give better support on VLLM, so we'll build the container accordingly. And then we'll have a sidecar inside it, which will do service discovery, authorization, metrics, audits, and so on and so forth. So audit is sent at multiple layers. It will be sent at the container layer, it will be sent at the service layer, and authorization again is managed at multiple layers as well, right? So this is basically how all of our models are deployed inside in our data centers as well as on our Azure GPUs, right? So the next part is basically the information, right? And we again built, this is like a very thin layer. The data store we typically use is Elasticsearch, though we are experimenting with some other stuff. And inside that you have different collections. We also provide different, when defining a collection and different fields, we support multiple embedding models, which is again running on our infrastructure only. So code will typically use something like Qwen, okay, and for text we'll use something else and so on and so forth. So you can configure all of that, feed it the data, and you can basically look up. So it provides vector-based lookups, and it will also provide attribute-based filtering, okay. So you can do both kinds of stuff there. So all of this is basically again managed at the upper layer by our existing ML platform. So ML platform is used to those containers that you saw for the models. They are all managed by the ML platform. And our platform can basically handle models all the way from GPUs right down to your phones, okay. So we do run, so that we don't have to again bring customers any data to the server side. We run some small models on the phone itself, and the delivery of the LLM to Drove to the small models that are running on your phone, all of them is handled by your ML platform, right? So yeah, so this is basically the platform layer we have kind of built till this point of time. We are working on adding other stuff. So there is, right now we can process images. There is a requirement now to sort of generate images, so we'll probably get into the territory that was discussed a couple of presentations back. So yeah, so we'll have to support all of that. So yeah, so we are building it as a requirement as the requirements come in. Excuse me. Yeah. So on top of this, so once this was done, like people started building a lot of stuff. We had already unlocked, if you're not using customer data, let's say developer productivity stuff, you can start using OpenAI APIs directly. And once this was ready, they have all been migrated to this platform. Okay. So yeah, so after this, what we saw was, as I said, like, so first we built for engineers because we knew when things don't work, we can use them to debug stuff, right? So once that was kind of working fine, we said, okay, let's help the other teams in the company. So PhonePe has a large operations team, right? You see all those QR codes and stuff on all the shops, right? So they are managed by like thousands of people, right? So and there's a lot of information. And even in engineering, there's a lot of information. Right? We have many platforms, different libraries, services, compliance, and so on and so forth. Right? So how do people understand? Right? So if say there is a platform X and somebody has used X, two people have created two Confluence pages. One is X, the other is how to use X in my service Y. Okay. So when somebody goes looking for X, they'll get all this information. I'm pretty sure it's a common problem, okay? It's good to have documentation, but once you have a lot of documentation, it's difficult to figure out how to actually, give out the correct information, right? So what we said is we'll basically build something like this. It's an internal tool, and I think this is right now the most popular internal tool used at PhonePe. It is a software. Basically, you can come, there are data stores that you can define. So I'll go to the architecture quickly, okay? So the architecture is very simple. You can come and define data source. They can be Google Drive folders. They can be Confluence. They can also be any service. Like the service that I said, we call it Autopsy. That's the RCA service. That is a data source. You can define that as a data source here. Then you have GitLab and Slack conversations and so on and so forth, right? Public channels. So any of this, a couple of channels you can take, or a subtree in Confluence you can take, a folder in GitLab, sorry, a repo in GitLab you can take, and whatever, some folder in Drive, etc. You create this kind of data source, and the Agent Hub will start indexing all of that, okay? And then what you do is you can define a configuration for an agent and say, okay, these are the data sources available, and it will give you some tools, predefined tools like web search and so on and so forth. So yeah, there's an agent here that can do DuckDuckGo lookups. Okay, yeah, so web search and so on. So you will have access to some of these tools. So we actually started with classic RAG here, okay? And the usual problem, right? The prompts getting filled up, and it was getting too much irrelevant information, and so on. So we basically moved to a tool-based lookup on Severus and tool-based queries on all the services that it interacts with. And again, it calls Godric. And this has been really useful for us inside the company to make for information, like for propagating information. So people use it all the time. How do I make API calls to service X? Okay. What do I do with service discovery, right? How does this service work, and so on and so forth. So we have other internal tools like, for example, documenting code repos. There are a lot of projects that are used every day, and most of them we build in such a way so that we can plug it into this. And right now, like tools, you can also expose other agents as tools to this. Okay, so you can build like multi workflow research agents, etc., on top of it. Okay, so yeah, so one of the things that happens, I'll give you a quick example. I think we'll run out of time. So we get all these notifications from RBI, and NPCI. Okay, there's a new product coming, or this is a new rule, or the limit for a particular type of transactions has increased, and so on and so forth. So there would be a folder with all the notifications from NPCI, right? And a new one comes, we can say, okay, what is the change that came in the new notification, right? So it just becomes really easy. And we have other monitoring systems inside, they are also integrated. So you can come, like Samir can say, for example, come and ask, how did payments do yesterday? And it will make sense of that all the way down because somebody has taught it, right? It has some memory as well. So somebody has taught, say, when somebody is querying on payments, you should go and look at this data source and so on and so forth, right? So this has been kind of really useful for us. But as I said, this all works out well for information. Now, what we typically are, as I said, is a Java shop, right? So all of our services are written in Java. So one of the major problems that you will see when integrating with different ecosystems is like you can create, say, a model. You have to make one API call. Very simple example. All of us have been there. Make an API call. The service provides a client library, but that's basically written in Java, okay, or whatever. It's written in Go. My thing is in Python, so I have to copy over all the model classes and so on and so forth, right? So, yeah, so we needed a simple agent-based system which can work across different types of models, like reasoning models, non-reasoning models, OpenAI and DeepSeek and Quen and whatever, right? So just thought we'll write something. The interface for this is kind of similar to Pydantic, etc., popular agent models. And it has a bunch of extensions which let you. So one of the things that we figured out, I think everyone would have figured out, and nobody talks about it in general, is like don't send a lot of tools to an agent, Like it gets completely screwed, right? You can't really work if you're sending like 40, 50 tools to an agent, right? So like it has extensions, and everywhere you'll see like whatever we have learned a little bit about building agents, etc., sort of encoded. So everywhere you have, you can compose a toolbox out of adding multiple MCP servers. You don't need to write code. You can basically write a config file. If a service accepts 20 parameters, and your query domain is only one, you basically fix 18 of them, keep 2 as parameters, and expose a tool on top of that which accepts only those 2 parameters. Okay, so it lets you do all of that. It has a memory extension, customized extensions you can create, and it has an agent registry where you can register your other agents, like basically write JSONs to create agents and have them used as tools in the actual agent, okay? So this kind of has helped us a bit as well for more complicated use cases which we want to deploy on our data centers, not really chat applications and stuff, though you can write stuff like that, but yeah, whatever. So let's say an agent which in case of, for anomaly detection, you'd want it running 24/7 on your data centers, right? Or network connectivity, network issue analyzer and stuff like that. So whatever we have to deploy to our data centers and needs to talk with services, this basically works really well. And yeah, so what we basically did is we open sourced this. It is present on our GitHub. And it comes with all the positives and negatives. Java is the Toyota of programming languages. If you know, you know, right? So yeah, so it comes with whatever positives it has, like super reliable, type safe, But we've tried to make the interface easy so that people who have been writing Pydantic and stuff can easily move to it, right? I don't want to read through it, but yeah, basically that whatever Java brings, this kind of brings with it. Yeah, so I think I'm done, right? So that's it. So a few things that we did is as I said, all of this new technology adoptions we typically tend to do in a more strategic manner. And to learn the tech, the best way is basically we started using it. And to start using it, we basically started building with it, right? And for building, we identified problems from the different teams. We literally called all the business leaders, etc., into a room and said, okay, can you list down what all problems you see we can solve with stuff, right? And we picked up a few and started building for this, and we are continuously building for it, right? And as I said, we are very paranoid about users' data, and we are that's one of the major drivers why we sort of started building stuff of our own rather than just calling outside providers and so on, right? And yeah, so standard interfaces. So if you're building something, always plan on interfaces that can work. Might not be perfect. There are some crazy conventions adopted in the OpenAI APIs, but it is what it is. The other tools have adopted to that, so it's better you basically stick to it, right? And yeah, so and we had built a bunch of platforms. So instead of again writing some stuff, we basically cobbled together whatever we could and wrote only the delta that was needed to enable the uh, use case. The major thing is we identified that this is something which can bring a lot of value all through the chain to us, and eventually I'm hoping to a lot of the people in the country. So we started investing and building early for it, right? And we'll take our time with this and build it out properly.